An insurer sells a single premium 20-year term policy with a face amount of $500,000 to age 38. Death benefit is paid at the end of the year of death. We can use the standard ultimate life table. There are no expenses. Interest rate is 5%. Single premium is $7,245. So immediately after issue, it is discovered that the mortality rates should have been 300% of the standard ultimate life table during the first 2 policy years, but then reverts back to using the standard ultimate life table mortality rates. And the premium is unchanged, so we want to calculate the expected loss at issue on this policy. So what they're looking for is this. So for that, we're going to need the expected present value of the death benefits, and we're going to subtract that by the premium. So for the expected present value of the death benefits, it's a little tricky because for the first 2 years, the mortality rates are different, but then we can use the standard ultimate life table. Okay, so we'll break this up into a 2-year term and a 20-year term. If they had the same mortality rates, then we would combine it, of course. But we're separating it because they have different mortality rates. So the expected present value of the 2-year term, well, this is going to pay $500,000 at the end of the year of death. So we want to discount it back 1 year. So if the person dies in the first year, well, the probability of dying is 3 times the mortality rate of the standard ultimate life table, which is 0.000463, plus, now we need to survive the first year, so that would be the complement of dying in the first year, multiplied, so we'll put it in front, 3 times the probability of dying using the standard ultimate life table. So the standard ultimate life table says it's 0.000493. Now we're going to discount it back 2 years. So we calculate this and get 1,331.25. 2 years done. Now I want to look at the 20-year term. So for the 20-year term, I want to discount it back to age 38. Okay, so let's say we're at age 40. We want to discount it back to age 38. So that means we have to survive 2 years at age 38, and then we have to discount it back 2 years. Okay, now we want to look at the expected present value. So at age 40, we know this is a 20-year term, so that's 500,000. Big A, 40 angle 20. Then we're going to put a 1 above the 40. So the person has to die within the first 20 years in order to get the payout. So we can express a 20-year term as the difference between an endowment and a pure endowment. So it's an endowment minus a pure endowment, so we'll just write it like this. And the nice thing is that starting at age 40, the standard ultimate life table mortality rates are used. So we can just grab these values from the table. Okay. Now for the probability of surviving, we could just grab the values from the top that we calculated. Okay. So that simplifies to 0.998611 and 0.998521. Okay, so we have 500,000, and then the 20-year endowment minus the pure endowment. So we simplify and end up getting 6,615.91. So the total expected present value of the death benefit will be this and that. Okay, so the 2-year and the 20-year. So if we add those up, we get 7,947.16. So this is expected present value of the death benefits. Okay. So going back, we said that the expected loss at issue was the expected present value of the death benefits minus the premium. So we just found the expected present value of the death benefits to be 7,947.16. There was only one premium, which is 7,245, which is 702.16, and that gets rounded down to 700, and that's the final answer.